Okay, welcome. In this video I'm going to show you a few examples of how to use polymorphism, and first thing I'm going to do is instead of creating the student object, which we will create a dynamic student object, and we will create a student pointer, and I'll call it a student ptr equals new student. So you have seen this syntax before, where we are actually creating a pointer, and then this is a new student object that we are creating using the 4-argument constructor. And whenever we use new, it's a good idea to always delete student pointer, so that we are not creating a memory leak. We are deleting that object, the dynamic object that we have created. Same thing here, we are going to create a new faculty object, and this new faculty object is pointed by faculty pointer, and we will delete faculty pointer. So we are deleting the object that we have created. Now we will also create a person pointer, which is the base class for both student and faculty class, and then the person pointer equals a student pointer and person pointer dot print. So we are calling, so let me compile this code and show you here. Sorry, there has to be a star here. Okay, okay, so this is actually upcasting, and since this is a student pointer, we need to convert this to a person pointer. So the person pointer can point to an object of, so let me do a okay, so I think what I did is I did not make it a pointer, so I'm going to make it a pointer and then compile, and then this needs to be a dot. Okay, so we have fixed most of our mistakes here, and there are some warnings which are reordering, and we'll talk about those later. Not important for now. So let me run this code, and you can see here we are creating a student object, we are creating a faculty object, and when I call print using the person pointer, because the print is a virtual function in base class, it calls the student's print function. So let me actually also print some information just like this, printing information, and then same way the person pointer can point to the faculty, or this is again downcasting, where we are converting the faculty object to a to the base class object, and then when we call person pointer dot print, it's going to call the faculty class's print function. So we can see that here it prints the faculty information. So everything looks good here. Now ideally what we would like to do is this. Let's say if we have a function which is print info, and this function takes in a pointer to the base class. So and then I'll just move this code here. For now I'm just showing you how this method is what we are going to do is just call the print info and then pass student pointer, and then we will call print info again, and we will call the faculty pointer. So that way what we are doing is essentially we are and we don't need the person pointer here. Okay, so now we have a print info which takes a pointer to a person, and person is the base class, so we could actually send any pointer to any derived class object, and that way we are calling appropriate methods of the derived class, the specific methods of the derived class. And that's what is the beauty of polymorphism here. We can say that the appropriate method based on the actual type of the class to which this pointer is pointing to will be called, because the print is the virtual function. So let me compile this code, and then if I run this, you can see we get the exactly same output because now we are doing this in the method. Another thing, quick comment, we want this to be a const because we are not changing the pointers here and the values, so that's always a good thing to do. And we don't get any error because print is also already, we have defined the print to be a function which is a const, which is promising that I'm not going to change the object, so that's always a good thing to do. Okay, now another thing I want to show is that we could also, instead of creating many pointers and then keeping track of the pointers, a lot of time we might just want to create a vector of objects. So let me include the vector class, and then we can create a vector of person pointer. Now this is very important. We are creating a vector of person pointers, and the idea is that because we can hold on, the pointers can be of person type, but we know that a person pointer can point to an object of the derived class, either student or faculty. That's what we are going to do. So we are going to create a new student object, and to keep things simple, I'll just say person pointer temp ptr, and I'll actually separate this out. So temp ptr equals new student, and we have seen that the compiler is fine with this. And then again, and then as soon as we do this, we will add this to the vector. So vector dot push back, and we will push the actual pointer, which is the dynamic object, to the vector. Now we don't have to keep that vector live because, or the pointer live, because now we have pushed that into the vector. So we could reuse this pointer that we have created and create a new faculty object this time and push that to the vector. Now interesting thing to note is that the objects that we are pushing to the vectors are of different types. One of them is a student object and another one is the faculty object here, but this is okay because now the vector is actually a person, is a vector of person pointers, and these are the actual object that we are creating are different types. So if you look at in a diagram, maybe I can show you here in well, you can think of the vector containing pointers, and these pointers are pointing to objects of different type. The first object is pointing to an object of student type. The second item or the pointer in the vector is pointing to an object of faculty type. And then actually we will not pass. I'm going to change this function. I'll still call it print info because we can overload methods. And now I'm going to pass a vector of person pointers, oops, and call it vec. So okay, and then since I don't want to make a copy of the vector, I'll pass it by reference. So now I have a vector here that I can access, and this vector is of person pointers that can have any types of objects. The pointers can be pointing to any type of object. So what I'm going to do is write a loop for int I equals 0, I is less than vec dot size I plus plus, and actually to avoid another warning I will just use unsigned int. And then what we are going to do is, there are two ways we can access the objects here. Either we can say vec I dot, and the only drawback is we don't get access to the methods directly, but that's okay, or we can write vec dot at I dot, and again this is a pointer. So I hope you get this idea. Each element in the vector is pointing to a specific object, and we are calling the print method on that object. And depending on the method whether the object is a student or a faculty object, we will have the appropriate method called and the information printed. So that's what I want you to see here. And another thing I'm going to change is, instead of calling print info now, or actually I'll comment this code, and now I will, for print info, we have two versions. I will pass now the vector here. So the vector. Also, this code is not going to work because I don't have the pointers, but if I just run this code, for now it's fine. You can see there is no errors. When I run this code, you can see as before, same thing. The vector contains two objects. One is a student object and the other is a faculty object, and depending on the type of the object, the appropriate print method is called. For the first one, on line 16, we are calling vec.print for each of the objects in the array, and the first one calls the student classes print method, and the second one calls the faculty classes print method. Now this is easy. We can add as many objects as we want of any type in any order. So I'll just add another faculty object, and we'll call this 124 Sean, and then ECE 150K, and then we are pushing that. And then when I run this, you can see now we have three faculty objects created, and then the first print is a student object, the second print is the faculty, and the third is the also faculty. Now to just make this code look a little bit more readable, I'm going to change a little bit in the person class. I'm going to remove the end L after the print so that there is no new line here. So now when I print this, and then maybe I'll add a space. Okay, and maybe an arrow will be good to just keep things information separate. Okay, so now when I call this, you can see, whoops, sorry, I just need a string here. Okay, so now when I print it, you can see we have three lines. The first line is a student object, the second line is a faculty, the third line is a faculty object, and all the information that we have put in is there. Okay, the last thing I'm going to do is we are creating a memory leak here in one sense, because we are not actually deleting the objects that we have created. So for that, we will create a method. I'll just create a method which will take the pointers, the vector, and then now this time we are actually going to remove const. So now we will run a loop which goes which processes each object, and this time we will say delete back I. Okay, so this time we are actually deleting each object in the vector, and compiling the code, everything looks fine. And now each of the objects in the vector will be eventually deleted. Well, I'm sorry, I didn't actually delete objects, and then I'll call delete objects here. Once we have printed and everything, we have done everything, we will do this. Okay, so our code works fine. We are creating three objects, printing the information, and then at the end deleting all the three objects so that we are not creating a memory leak. Okay, that's it for now. If you have any questions, feel free to write comments or send me email.